So this is a make-believe field, the Vibranic Field, based on vibranium from the Marvel Universe. The question asks, what force must Captain America apply to his shield to keep it at rest while inside the VF room? And that's described above. So if I draw a free body diagram for the shield, that will have gravity, it will also have this new make-believe force that's due to this vibranium field. And it's described as any object inside this field that contains vibranium metal will feel a force of 10 newtons up for every liter of vibranium. The more vibranium there is, the more force it will feel. So it's going to feel an upwards force. And that's going to be 10 newtons times how many liters of vibranium the shield is made out of. So I'm going to call that FV. I'll use the subscript of V for vibranium. And I drew that arrow longer than gravity just because I did some mental math here. So the force due to the vibranium field, it's going to be 10 newtons times however many liters of vibranium there are, and the question says there's 35 liters. Actually, I'll put the units into this so maybe you better understand. It's 10 newtons per liter of vibranium times 35 liters. That results in 350 newtons up. Whereas the force of gravity is mg as usual. So that's 5.4 kilograms times 9.8 newtons per kilogram. There still is the gravitational field here, just in addition to the vibranium field. So 5.4 times 9.8 I think is less than the 350. That's why this arrow is smaller. Or maybe not. Oh yes, it's definitely small. It's only 52 newtons, or 53 newtons. Okay, so therefore, in order to keep the shield at rest, Captain America must put an applied force on it. So this is not really to scale here. Or let's make this a bit better to scale. So 350 up, 53 is a lot smaller than 350, so I'll make the arrow a lot smaller. And then Captain America will have to put an applied force down. So FA for applied force. And we have to find out how much that is. It's basically going to be 350 minus 53. That's just intuitive. Like, it's what it needs to be to make everything add up to 0. So that's going to be 497 newtons. No, 297 newtons. And it has to be down. That's part of the question too, to figure out which direction the applied force has to be.